So today we are here to do the doubt solving sessions for the GATE under the Ekeeda platform for the subject Geomatics Engineering, or also called as surveying. Right. So in the previous session we have already done with the fundamentals of surveying as well as the chain surveying. So today we will be dealing with certain questions of complex surveying as well as leveling, and if time permits we will also do it for traversing. Okay, so based on how much time we have, we will do it. So everyone can use the live chat option to talk to me in case you have any doubts regarding today's topic of discussions. You can ask me. Okay, so let's get started. So today's topics will be, as I told you, compost surveying, leveling, traversing. Okay, so any doubts in this, if you have, you can ask me, or else we will start with the session where I will be solving certain MCQs which will be helpful for your exams from the topics of compost surveying as well as leveling. Okay, so what you can do is you can just use the live chat option to let me know if you know the answers. So you can type the question number, and with the question number you can type the correct option. If not, I will also help you in explaining each question. Okay, so let's get started. This is the first question on complex surveying. So what does it say? An azimuth is a true bearing, magnetic bearing, arbitrary bearing, and the option number D is none of the above. So what exactly is it? Azimuth. The answer for this is your true bearing. So the direction which shows the true north and true south. Okay, so especially the true north, that type of bearing is called as your azimuth or true bearing. If the bearing or the angle, bearing is nothing but angle. If this angle is measured from the true north, then it is called as the true bearing or the azimuth. If it is measured from the magnetic north and magnetic south, then it is called as magnetic bearing. Arbitrary bearing is you can choose any one random direction and from there take up the angle, that will be your azimuth. Okay, arbitrary bearing. So for all the people who are new to the Ekeeda platform and haven't downloaded the app yet, you can go to the Play Store, or also in the live chat you have the description or the link to download the app. So you will get our academic courses, GATE courses, and all other competitive exam courses and professional courses for all the branches of engineering here. So you can go and have a look. So we have recorded sessions, we conduct live sessions like this on the YouTube platform for doubt solving. Also we provide you with the complete notes. Then you can use gold 11 code for getting a 3 days complete free access for the entire courses in the app, so that you can have a look on that. Okay, so for anything you can just download the app and ask your queries. Okay, chalo, next let's move to the next question. So this is your second question. What does it say? The magnetic bearing of a line See, so far I am telling you bearing is nothing but angle. So he's given you the magnetic bearing. So the magnetic bearing of a line is given to you. The line name being AB. How much is it? 1320 degree, 132 degree, 45 minute. The magnetic declination is given. How much? 10 degree, 20 minute west. He is asking you what exactly is the true bearing. Okay. Now what will happen is, say this is your true north, but the magnetic north might be either here like this, or it may be, so okay, let me first finish one side. So this may be your magnetic north. See, if you observe, this has declined towards west, right? This difference is called as declination. What is it? The magnetic declination is the horizontal angle with the magnetic meridian makes with the true meridian. Whichever magnetic meridian angle is made with the help of the true meridian, that particular declination is called as magnetic declination. Now if it is westwards, it is called as westwards declination, right? And westward declination is always taken as negative. Whatever I have written in black is for westwards declination. Now let us go for eastward declination. So if the declination is eastwards, then it is always positive. Okay. So the formula which holds good for your true bearing is what? True bearing is equal to magnetic bearing plus or minus declination. Now this plus or minus depends upon whether it's east or west. For east it is plus and for west it is minus. Now consider the given question. He has given you the magnetic bearing as well as the declination. Now the declination is 10 degree 20 minutes west. West means we have to take negative. So 32 degree 45 minute minus 10 degree 20 minute. If you do, you will get your true bearing. How much is it? 122 degree 25 minute. Okay. So what he is trying to explain here is, so this is your true north. Okay. There's a line here. There's a line here. I will call this line as AB line. Okay. When it is being measured from the magnetic north, it was giving an angle of how much? 132 degree 45 minute. It had a westward declination of 10 degree 20 minute. So actual from the true north, how much it is? He is asking you. So from 1 to 132.45, if you remove the 10 degree 20 minute, you will get the true bearing. Okay, I hope the question is clear. Okay, let's move on to the next question. So in a prismatic compass, the graduation starts from 0, marked at the dash end of the needle and runs in which direction? So in prismatic compass, where exactly is where exactly is 0 marked, he is asking, and it will run in which direction, whether it's in clockwise or anti-clockwise direction, they are asking. So the correct answer for this is south and clockwise. So in prismatic compass, always the 0 marking will be in the south and it will run in clockwise direction. That is, the angles are measured in clockwise direction. Okay. So how exactly it will look? Compass like this. Say if you have the compass, this is your south, this is your north, west, and east. So it is marked 0 and runs in clockwise means this will be 90, this will be 180 and this will be 270 degree. Okay. So this is how it will work. Next, let us move on to the next question. Question number 4. So what is it telling you? If whole circle bearing of any line is W1, that of a preceding line is W2. So preceding line is the previous line. Say for example, we have one line. So here this is W1, the whole circle bearing of this line. Okay. And the preceding line is nothing but the previous line. And for the previous line, the whole circle bearing is how much? W2. And D is the deflection angle to the right. The deflection angle to the right. What is deflection angle? The angle between the line and the preceding line. The upcoming line and the previous line. This is called as the deflection angle. Okay. So then choose the correct expression. Choose the correct expression. See now, you can tell from the figure what will be the correct expression. Your deflection angle delta or D will be equal to what? The whole circle bearing of that line minus the whole circle bearing of the preceding line. Okay. So W1 minus W2, if you do, you will get the value of the delta. See from north, this is measured from north, this is also measured from north. So if you remove W1 from W2, you will get this whatever angle which is your delta. So is this expression there in the question, in the options? No, it is not there. So try to rearrange the expression. Everything is in terms of W1. So if you send this on the other side, your W1 will be equal to what? W2 plus D. Is this expression available? Yes, it is available. So the correct expression is W1 is equal to W2 plus D. This will be your correct answer. Okay. Let's go ahead to the next question. In surveyor's complex, the bearing observed are in whole circle bearing, reduced bearing, both A and B, none of the above. So for this, the correct answer is reduced bearing. So basically, you need to know the difference between the prismatic complex and the surveyor's complex. So in surveyor's complex, the readings are in reduced bearing. Reduced bearing means the angles will be only from 0 to 90. The varying will be only from 0 to 90 and the measurements can be either from north or from south, whichever is closer. And if it comes to prismatic complex, the measurement is always from north in clockwise direction and they will be in whole circle bearing system, that is from 0 to 360 degree. Okay. Next question. So what does the question say? An important question. This is a question about the local attraction. So what is it saying? The following bearings were observed while traversing with a complex. Which stations are affected by local attraction? So they've given many stations in which the bearings have been done. They're asking which stations exactly were affected by the local attraction. What do you mean by local attraction? The attraction of your magnetic needle to a local magnetic field other than the earth's magnetic field is called as what? Your local attraction. So if there is any iron pipe or steel bar or vehicles, that will cause what? Local attraction. So how do we identify the local attraction? The local attraction is identified by observing the forebearing and back bearing of a line. Okay, so if the difference between the forebearing and back bearing of a line is exactly 180 degree, then it means that both the stations are free from the local attraction. If not, if not, there is one station which is affected, or it may be that both the stations might be affected. Okay, now how do you identify? See here, first try to take the difference between this forebearing and back bearing. So how much is it? Minus 104 30. So this will be 0.081. So exactly 180 degree. Moving on to this, how much is it? 226 degree, 48 degree, 15 minutes. So how do you convert 225 degree 60 minute, 48 degree 15 minute? So if you observe, 45 minute is coming as a difference. So it's coming equal to 187 45 minute. When you check this, see this also here, observe there's a difference of 15 minute. Then in 290, remove 115, it will come as 175 degree. Next, lastly, move on to this. So 357 minus 180. So this will be 177 degree 0 minute. So if you observe, only this is the one which has the difference exactly 180 degree. All others have a difference not equal to 180 degree. So station A and B are what? Are free from local attraction. Okay, so what is he is asking in the question, which stations are affected, which stations are affected by local attraction is what he is asking. So A is not affected, B is not affected, you know that. So in this option you have A, so this will not work out. In this option C and D, so this option B is the correct answer. Okay, because here A and B is there, this is also not correct, and here B is there, this is also not correct. Is it clear? Okay, let's move on to the next question. Question number 7. So the forebearing of a line is, so they have given the forebearing of a line which is north 30 degree east, okay. Now they're asking us to find the back bearing. See, this is in which system? This is in reduced bearing system. The angle measured here is in reduced bearing system. Okay, whenever they mention the directions on the two sides and the angle in between, then it is in reduced bearing system. So if you want to convert the forebearing into back bearing in case of reduced bearing system, what you have to do is just change the directions. Convert the north to south or south to north, vice versa, and east to west and west to east, vice versa. So here north is there, this will become south, 30 degree will remain as it is, and east will become west. Is it clear? This is the trick which you have to remember. Okay. So what is the correct answer? South 30 degree, west is the correct answer. If not, if you don't want to remember the trick, you can go by the basic. How will you go by the basic? See, this is your north, south, okay. This is your east and this is your west. So they have given as north, east, 30 degree. So where will the line come? The line will come here. This is 30 degree. Right. Now what will be the back bearing of this? Exactly add 180 for this. If you add 180 for this, where will the line come? The line will come somewhere here. This is 180. Okay. So if this is 180, the remaining portion is again 30. So now the back bearing of this particular line will be what? Southwest, southwest 30. Right. So it's better to go by the trick because it will be faster. Okay. Moving on to the next question. What does the next question say? If the magnetic bearing of the sun at a place at noon in southern hemisphere is 167 degree. So what is given? The magnetic bearing at noon is 167 degree. They are asking the magnetic declination at that particular place. So for this, the important thing which you have to remember is the true bearing of the sun at noon in the southern hemisphere is always how much? 180 degree. Noon means exactly in the afternoon at 12 o'clock, right? So at 12 o'clock, the true bearing of the sun will always be how much? 180 degree. Now he is telling that the magnetic bearing is 167 degree. So we know the relationship between magnetic bearing and true bearing. What is it? True bearing is magnetic bearing plus or minus declination. Right. So what you can do or write it as magnetic declination. So magnetic declination is equal to your true bearing minus magnetic bearing. True bearing is 180, magnetic bearing is 167. So how much will be the declination? It will be 13 degree. Since it is coming positive, positive declination is always what? Eastward declination. Okay, so east, 13 degree east. Do we have it? Yes, 13 degree east. See, don't get confused. They have also given the option of 13 degree west. Only in order to confuse you, they have given 13 degree west also. If it is positive, it's always east, and never magnetic declination is told in north or south. It is only told in east or west. Okay. Hello, Dinesh. Welcome to the class. Yes, you're right. Okay, let us move on to the next question. Question number 9. Whenever you're giving the answers, I would request you type the question number and then the correct option so that if there is any lag, I will be able to understand for which question you have actually answered. Okay. Ah. If the end points of a line are free from local attraction, the difference between the back bearing and the forebearing of that line should be. So if any station is free from local attraction, the difference between their angle should be how much? 180 degree. Yes, Dinesh, very good. Correct answer. Let's move to the next question. Question number 10. So what have they asked you? Bijesh, correct answer. Okay, let's move to the question number 10. Welcome to the class, Bijesh. The forebearing of a line is given. So I've given the forebearing of the line. The back bearing of the line is. The back bearing of the line is being asked for you. So before you give me the answer, I would like to write the formula for this. So whenever back bearing is asked, forebearing plus 180 degree. If your forebearing is less than 180 degree and your back bearing is equal to forebearing minus 180 degree if your forebearing is greater than 180 degree. Check properly, Bijesh. Check properly. See, the back bearing is what? 4 bearing plus 180 or 4 bearing minus 180 depending upon what the 4 bearing is. Okay. Now you observe the 4 bearing given to us is equal to how much? 324 degree 45 minute. This is greater than 180 degree. So what should I use? Back bearing is equal to 4 bearing minus 180 degree. So 324 degree 45 minute minus 180 degree. So how much will it come? It will come 144 degree 45 minutes. Ria, correct? So the correct answer is option number A. I hope you understood. Brijesh, Dinesh, Ria. Ria to gave right answer. Brijesh and Dinesh, I hope you understood. Okay. So this is the correct answer. So you need to remember this relationship for doing any uh, problem regarding forebearing and back bearing. Plus 180 if forebearing is less than 180 and minus 180 if forebearing is greater than 180. This is the important thing you have to remember. Okay, let's go on to the next question. Question number 11. Compute the angle between the line AB and AC if their respective bearings are. So they have given you two lines and the bearing of both the lines has been given to you. So the first line is AB. See how much is the bearing of AB line? So the bearing of AB line is 52 degree 30 minute. Okay. So where does 52 degree 30 minute lie? Whole circle bearing. We assume that it is starting from north. So this I will take as line AB and the bearing for this is how much? 52 degree 30 minute. Now what is it telling? There's one more line AC and the bearing of AC line is how much? 328 degree 45 minutes. So where does this lie? So if you all know that this starts from 0 here, 90 degree, 180 degree, 270 degree and again it comes back to 360 degree. So your 328.45 will lie somewhere here. So this is the line AC and the angle for this is how much? 328 degree 45 minute. Now what exactly is he asking you in the question? Angle between the lines. Okay. So the angle between the lines will be this green portion. BAC will be the angle between the lines. Now how do you compute it? So try to find this particular value, star value, that is nothing but your. So can I write a BAC angle as BA north or BA north plus north AC. So BA north is already 52 degree 30 minute and north AC will be how much? So in total 360, if I remove 328.45, 328 degree 45 minute, will I get it? Yes. So on simplification, what will it be? 83 degree 45 minute. Okay. So 83 degree 45 minute. Do we have that option? Yes, we have it in option number D. So this is your correct answer. Okay. Let's move ahead. Question number 12. The whole circle bearing of a line is given. So we have to convert it to reduced bearing. So as I told you 0 degree and it starts from north, 90 degree, 180 degree and 270 degree. This is north, south, east and west. Now where is that line coming? 28. So it will come somewhere here. Okay. So this entire value is how much? 287 degree 15 minute. So how much will be the remaining portion? How much will be the remaining portion? So the red portion will be equal to how much? 360 minus 287 degree, 15 minute. So this will be 72 degree 45 minute. Okay, do we have? Yes, we have only in one option 72 degree 45 minute. So this is your correct answer, right? Even if not, how will you identify if this is 72 degree 45 minute? We are in reduced bearing, always measure from north or reduced bearing, we measure either from north or south, whichever is nearer. No, for this red angle, the nearer direction is north. So north 70 degree 45 minutes, west will be your correct answer. That is how you have to identify. Is it clear? I hope everyone is able to understand. Chalo, let's move ahead and move on to the next question. The angle between true meridian and magnetic meridian of the time of observation is known as. So, just uh, before some time we discussed this question, right? So, the angle between the, I mean, in a different format we have discussed this question. So, he is asking you what exactly is the angle between the true meridian and the magnetic meridian called. So it's called as what? Magnetic declination. B is your correct answer. B, not dip. Ria, dip is nothing but if there is a needle like this, the deflection of the needle, vertical deflection of the needle is called as dip. Okay. So the difference between the true meridian and the magnetic meridian is always called as magnetic declination. Okay. Ha, Dinesh, you are right. Okay. Let's move on to the next question. That's why I suggest you to write question number and then type the option like this. It will be easier for me to understand. Question number 14. Question number 14. The forebearing of the line AB and BC are 40 degree and 120 degree respectively. The included angle between AB and BC. So they have given the forebearing of a line. First, let me take AB line. So this is north. Whenever you are drawing bearing, try to put the north. This is A and this is B. So for this 40 degree is given. So I have taken it in the first quadrant. Now for the line BC, it is 120 degree. 120 degree means in the second quadrant. Here it will be, and this will be equal to how much? 120 degree. What is exactly being asked to you in the question? The included angle between AB and BC. Which will be the included angle? This will be your included angle. Okay, how to identify? See now this Z angle, this is 40, right? And how about this portion? How about this portion? This portion, if you want to calculate, how about it? So you have 180 minus 120 because from north to south it will be 180, but the bearing of this line is already 120. So that will be 60 degree. So this portion will be 60 degree. So what will be the included angle? ABS plus SB. This is actually C. Okay. So 40 degree plus 60 degree. That will be equal to 100. Dinesh, very good. Correct answer. So the correct answer is what? 100. Okay. Chalo. Let's move to the next question. I hope you understood. Is everyone able to understand? Yes. Chalo. Question number 15. Ah. In a quadrantal bearing system, see, quadrantal bearing system is nothing but the other name for reduced bearing system. As I told you, in reduced bearing we either express it from north or south and the angles only will be between 0 to 90 degree, and we can measure in clockwise as well as anti-clockwise direction in this right? And in whole circle bearing system, this is for reduced bearing system, and for whole circle bearing system we have to measure only from north, and the angle is from 0 to 360 degree, and it's always in clockwise direction. This is the major difference you will have to remember. So they have given quadrantal bearing system for you. We have to convert it to whole circle bearing system. So try to put the figure, it will be faster if you try to put the figure. 15th one C, everyone is saying 15th one C. Yes, will let us check. Amit, what is this? I didn't get your question. What is this class about, or what is this question about? We are doing geomatics engineering or surveying questions on compost surveying. Okay. So everyone is saying 15C. Let us just have a quick look whether it's correct or wrong. So bearing is given as how much? 290. So this is 0, 90, 180 and 270. So obviously it will come in the fourth quadrant. So this is equal to 290 degree 30 minute. So what will be the remaining angle? The remaining angle will be 360 minus 290 degree 3 degree 30 minute. So how much is the remaining angle? 66 degree 30 minute. Okay, 66 degree 30 minute, and north is nearer. So north west will be the answer. Yes, everyone gave the correct answer. Very good. Let's keep going. Question number 16. This everyone is going to give me. We have solved a similar type of question. When the magnetic bearing of the sun at noon is, so we know the true bearing of sun at noon is always how much? True bearing of sun at noon. Noon is exactly at 12 PM. It's always how much? 180 degree. So they have given you the magnetic bearing, which is 185 degree 20 minute. So your magnetic declination is equal to true bearing minus the magnetic bearing. How much is true bearing? 180 degree. How much is the magnetic bearing? 185 degree 20 minute. So this will be minus 5 degree. No, minus correct. Minus 5 degree 20 minute. So what is the meaning of minus? Minus means the declination is westwards. If it is plus, the declination is eastwards. So for the 16th one, the correct option is what? 16 one is C. 16 is C. Yes, Dinesh, 16 is C. Correct. Correct. Don't get confused. Don't get confused. You tried to say B, but it's not B because we got minus sign. It is always westward. Okay. I hope you understood. It's clear. Let us move ahead and go to the next question. Question number 17. Easy again. Whole circle bearing is given. Whole circle bearing is given. 210. 210 means it will come here. Yes. So this is 210 degree. So I would like to calculate this angle. This angle will be how much? 210 degree minus 180. That's equal to 30. So everyone, all the angles are 30 only here in the options. But if you observe south, this is south, and east and west. So it will be southwest 30. Southwest 30. Do we have? Yes, we have it. So that is the option number A. Yes, Ria, very good. You should be quick because these are easy questions, right? So easy questions they are. The magnetic declination is the difference between true meridian and the magnetic meridian. अरे यार बहुत बार पूछ लिया question. Repetitive. Okay. हाँ. If the forebearing of a line is observed to be, so they have given you the forebearing of a line, which is 12 degree 24 minute. They are asking you to find the back bearing of this particular line. So as I told you, back bearing is equal to forebearing plus or minus 180. We use plus when forebearing is less than 180, and we use minus when forebearing is greater than 180. Okay, so now in this particular question, our forebearing is less than 180. So what we use? We use forebearing plus 180. So 12 degree 24 minute plus 180 degree. तो कितना हुआ? 192 degree 24 minute. Yes, very good, Ria. The option is option number D. The correct answer is option number D. Okay, let's skip to the next question. Oh. The direction of the line relative to a given meridian is known as. What do you call the direction of a line relative to a given meridian? Angle of line, direction of line, bearing of line, relative meridian. Relative meridian. What is it? Anyone knows the answer correctly? Anyone who knows the answer correctly? What is it? It is option number C, right? Bearing of a line. Okay, shall we move ahead? Question number 21. The horizontal angle between the true meridian makes with the magnetic meridian. See here, in order to confuse you, he has given two terms, magnetic declination and true declination. It's always magnetic declination. There's nothing called as true declination. Okay, so this is your correct answer. Let's go to the next question. What does the question say? If the bearing of AB is north 40 degree west and bearing of BC is south 70 degree east, then the angle of ABC. Okay, let us first plot the lines ABC, AB and BC. Okay, so this is your north, south, east and west. AB bearing is what? Northwest. So it is here and this is 40 degree. So this is your line A, B. Okay, so let us change the color so that it will be easy for you to identify. Next, BC. BC is southeast. Now see, observe. So this whatever I drew, okay, I have to erase this because this whatever I drew was AB. Now AB will extend till here. Now we have to go for BC. Okay, let us call this point as B. Now we have to go for BC, so I'll have to draw a different direction profile for this. So north, south, east and west. So BC is how much? BC is southeast 70. Where is south? Southeast and 70 somewhere here. Okay, so this entire value is how much? 70 degree. So this is your BC line. So what are they asking you? They're asking you to find what is ABC angle. So you'll have to be very careful in finding this. Right. Now do one thing. Now this is 40 degrees. So if you take Z angle, see this is north, you go like this and come to this. So this is also 40 degree, right? But the total value is 70 degree. So how much is remaining? 30. So the exact answer for this is how much? 30 degree. Okay. Is it clear? I hope everyone is able to understand. Yes, let's move to the next question. In compost surveying, the direction of lengths of survey line is measured by compacts. The direction is measured by compacts. The length of the survey line is measured by chain or tape. Only A, only B, only C, both B and C. Which one is correct? He is asking you. So what is the correct answer? The correct answer is both B and D, because compacts will help only in the measurement of direction, whereas the length will be measured using the chain and the tape. So both option B and C are correct. So this will be your right answer. Chalo, next question. In the prismatic compacts, the graduation rings attached to the compacts moves with sight. Usage is not possible without a tripod. The needle remains stationary when the box is rotated. Whole circle bearings are calculated. So he is asking you which is the correct one. So the correct one only is the option number D. None of them are correct related to your prismatic compacts. All this comes to surveyors compacts. Okay, next. True meridians are parallel to each other, converge at a point called pole, converge near equator, none of this. So they will all converge at a point called pole like this. So this is your say north, south, like this, like this, like this. They will all converge at a point called as pole. So these are called as poles, north pole and south pole. So the correct answer is option number B. Let's move ahead, go to the question number 26. Inclination of the compass needle to the horizontal towards the pole is called as dip, declination, azimuth and bearing. So this is called as dip. Okay. Inclination of the compass needle. Like this, it will try to incline with respect to the horizontal line. This is called as your dip. The dip of the compass needle is constant, varies from place to place and zero at the equator and maximum at the poles is zero at the equator and poles. None of this. So the correct answer for this is option number B. Why? Because the dip varies. So generally the angle of dip will be zero at the equator. Dinesh, no, it will not be 0 at both equator and pole. At the equator it will be 0, but at the pole it will be 90 degree. Okay, so correct option or the answer is answer number or option number B for the question number 27. Okay, next question. Magnetic declination remains same at different places, varies from place to place, does not vary with temperature, none of this. How about magnetic declination? Magnetic declination is what? If there is any magnetic field over, then so this will vary from place to place. This is the correct answer. Always varies from place to place. Chalo, next question. Question number 29. The quadrantal bearing of the line lies in the third quadrant, making an angle in clockwise direction with the north. So in third quadrant, like this. There is the quadrantal bearing. There is a line which is in the third quadrant. Okay, I've put a line in the third quadrant. Okay, making an angle in clockwise with the north. Okay, this entire thing I've taken as theta. Now suppose I want to write it in the quadrantal bearing system or the reduced bearing system. How will I write is what he is asking. Okay, now first try to find this angle. How much will this angle be? It will be 180 minus theta, right? It will be 180 minus theta. So south 180 minus theta, sorry, not 180 minus theta, correct, theta minus 180, theta minus 180 because it's greater, no? Missed out of my mind. Yes, Ria, you're correct. So this is 180 theta minus 180 and it is in southwest. So the correct answer or the option is option number D. Let's move to the next question. The difference between the forebearing and the back bearing of any station is equal to external angle, internal angle, either external or internal angle, and right angle. So it's always equal to what? The internal angle. It's always equal to the difference between the forebearing and back bearing is always equal to the internal angle. Moving on to the next question. The value of whole circle bearing varies from very easy 0 to 360 degree. So this is your correct answer. Ah. Now carefully read the question and try to answer it. Yes, very good. D was the correct answer for that. Now, which of the following is the correct statement for a station that is affected by local attraction? So he is telling the station is affected by local attraction and he wants the correct statement for it. Difference between the forebearing and back bearing is always equal to 90 degree. Difference between the forebearing and back bearing is always equal to 180 degree. The difference between forebearing and back bearing is not equal to 180 degree. The difference between the forebearing and back bearing is always equal to 360 degree. See, this is the wrong because it doesn't be, it cannot be 90, it cannot be 360. Now whether it is equal or not equal, you have to tell based on the question. He is telling it is affected by local attraction. If it is affected by local attraction, it will not be equal to. So exactly correct, Ria. So the answer is what? Option number C. Lot of you tend to misread the question and write equal to 180 because we have read accordingly that station with without local attraction is equal to 180. Okay, so tend to don't be in a hurry to read the question. Okay, next question. The forebearing of a line is 30 degree. Calculate the back bearing of a line. Very easy. So back bearing is what? Forebearing plus 180. Why did I use plus symbol? Because forebearing is less than 180. I should use plus symbol. So 30 degree plus 180. How much is it? 210 degree. So the correct answer is option number C. By now this formula should be fixed in your mind. Right, next question. Interesting question. Read carefully, give me the answer. Very, very good question. Calculate the magnetic declination if the magnetic bearing of a line is. So they have given you the magnetic bearing of a line. How much? North 81 degree east and true bearing also is given. How much? North 77 degree east. Try to first put the values. Okay. So this is true north. So from true north, whatever we measure will be what? True bearing. So this is 77 degree. This is northeast. Right. And from magnetic north, see this is greater than true. 77, 81 is greater than 77. So obviously it is behind. Okay. And this is how much equal to? This is equal to 81. So the difference is how much? The difference is 4 degree. And which direction is this? Eastward or westward? It is westward. So What is the correct answer for this? Minus 4 degree westward. Very good. Very good, Ria. So this is your correct answer. Okay, I hope you understood how to do it. Chalo, next question. Calculate the true bearing of the line if the magnetic bearing is, so true bearing is what? Magnetic bearing plus or minus magnetic declination. So magnetic bearing is given as south 60 degree east and magnetic declination is eastwards. Eastwards means plus 5 degree. So south 65 degree east will be the, no, you have to first convert it into whole circle bearing and then do the problem, or else it will be wrong. Please convert it into whole circle bearing and then do the problem. So first of all I'll write southeast. Southeast is this side, no? South is 60. So this is 60 degree. This is south and east. So what will be the exact angle of this particular line? Exact angle will be, or whole circle bearing will be 120 degree. No, Ria, it's wrong. That's what I also tend to do. So you should be very, very careful. You try to convert this into whole circle bearing and then convert it to reduced bearing, or else your answer will be wrong. Okay, see now what did I do? Southeast I converted to whole circle bearing. How much the whole circle bearing? 120 plus 50. So how much I got? 125. Hi Rajat, good evening. Welcome to the class. So now the whole circle bearing is how much? 125 degrees. So this is 125. So what is remaining? 55. So what it will be? Southeast 55. Yes, this is your correct answer. You understood? If you directly try to add this 5 to this 60, you will be wrong because southeast you are coming in this direction, but eastward you are going in this direction. Okay, so the directions of the angle won't match. So whenever they are asking you to find the true bearing or magnetic bearing or declination and they give you reduced bearing system, please try to convert it to whole circle bearing system and then do the problem. Ria, understood? You gave wrong answer. So I hope you understood the correct concept. Shall we move ahead? Chalo then. If you have any doubts, you can ask. If you have any doubts, you can ask, or else we will proceed. Yes, you understood. Okay. So let's proceed to the next question. Question number 36. If no error in the magnitude, the difference in the magnitude of the forebearing and the back bearing of any line is always a simple question. It's always 180 degree. So I'm not waiting for this question. Okay. Chalo, give me the answer for this. Fatafat. Calculate the whole circle bearing of a line if the reduced bearing is given northwest. Northwest 30 means this much. So what will be the whole circle? This will be the whole circle bearing system. How will you calculate it? 360 minus 30. That will be 330 degree. Correct answer. Yes. Yes, very good. Very good, Dinesh. Chalo. Ha. Important question or good question, standard question it is. Which of the following is true for the limit of accuracy in compass surveying? Limit of accuracy in compass surveying should not be more than 5 minutes, should not be less than 5 minutes, should not be more than 10 minutes, should not be less than 10 minutes. Rajat, correct? Yes, anyone? So here the answer should not be more than 5 minutes. The accuracy should not be more than 5 minutes. Okay. Chalo, next question. Which of the following is correct for whole circle bearing? It is always measured in clockwise direction. Is it? No, it's not measured in clockwise direction. Sorry, anti-clockwise direction. It is measured in clockwise direction. It is always measured in anti-clockwise direction from south end to south end of the reference. No, it is measured in clockwise direction from the north end. So it is always measured in clockwise direction from the south end of the reference. No, this is wrong. This is correct. Then it always measured from north end of the reference. So the option or the correct answer is option number D. Correct. Dinesh, you're right. So the correct answer is option number D. So in whole circle bearing system, we measure from 0 to 360 degree always from north and in clockwise direction. In reduced bearing system, the angle is between 0 to 90 degree measured from either north or south and also in clockwise or anti-clockwise direction. Don't forget this difference, a very important difference which you have to remember. Next question. What is the declination if magnetic meridian is towards the west side of the true meridian? So easy question. What is it? What is the answer for the question number 40? Everyone will give me the correct answer. So where is the magnetic meridian? If this is the true meridian, this is the magnetic meridian and this is west side. So if it is west side, yes. Very good, Dinesh. So it is Ria, correct. Very good. Chalo, next question. Calculate the reduced bearing of the line if its whole circle bearing is 130 degree. Whole circle bearing is how much? 130. So where will the line come? North, this one, 130. Okay. So south, east, west. So how much will this be? 180 minus 130. So 50 degree. So this will be 50 degree. So south 50 degree, east is your correct answer. Yes. Correct. C is your correct answer. Very good, Dinesh and Ria. Chalo, next question. Carefully, please do the question. Carefully do the question. Forebearing and back bearing of the lines of a traverse are as follows. So line is given, forebearing is given, back bearing is given. Which of the following station is free from local attraction? So try to take the differences. Mm. So I'll write the differences in the center. क्या आ रहा है देखो 304 minus 125 179 and 351 minus 172 again 179 264 minus 83 again 181 and 316 minus 136 180. So this is coming 180. So E and D and E are free from D and E are free from local attraction. So in the option here A is given, so cannot be possible here. A, C not possible here. C not possible. So only D is the correct answer. Actually, E is also correct, but in the options we don't have it. Yes, Dinesh, you're right. Okay, understood. Chalo, let's move to the next question. Mm. Magnetic bearing of a line is 35 degree 45 minute. The declination is 3 degree 45 minute east. East means you have to add it. True bearing is equal to magnetic bearing plus magnetic declination. This is your magnetic declination. So just add them, 35 degree 45 minute plus 3 degree 45 minute. So 90 carry out 139 degree 30 minute will be your answer. Okay, so D is your correct answer. Next question. If the observed forebearing of a line AB is, so forebearing is given how much? 202 degree 30 minute. This is greater than 180. So forebearing will be what? Sorry, back bearing will be what? Forebearing minus 180. So 202 30 minus 180. So it will be 22 degree 30 minute. Do we have? Yes, we have the answer. That is option number B. Next question. In compass surveying, if the whole circle bearing, so they have given the whole circle bearing. So in whole circle, this is 270, 180, 90, 0, 360 and north. So where is it? Here somewhere. Okay, this is equal to 237 degree 45 minute. Now I have to find only this portion. So how will you find only this green portion? So that will be 237 degree 45 minute minus 180 degree. So 237 minus 180. How much? 57. 57 degree 45 minute. Okay. But they have given in the quadrantal bearing. So quadrantal bearing south west. Southwest will come here. South and west. Yes, you are right. Option number A is correct, Dinesh. Chalo, next question. The graduations marked in the surveyor's compass varies from dash to dash, 0 to 270, 0 to 90, 0 to 360 and 0 to 180. Okay, who will give me the correct answer? Surveyor's compass. Yes, very good. The option is 0 to 90. So if in case they ask you prismatic, what is the answer? Because prismatic bearing works in whole circle bearing system and surveyor's compass works in reduced bearing system. For prismatic it is 0 to 360 and for surveyors it is 0 to 90 degree. Very good, Dinesh. Let's move on to the next question. If a line AB has a whole circle bearing between 90 to 180, then the correct expression used to calculate reduced bearing is, how will you do it? So where is the angle? This is north. It is between 90 to 180. So the line will lie somewhere here. Okay. So reduced bearing angle will be this. Say if this is the whole circle bearing, total will be how much? 180. So 180 minus whole circle bearing will give you this particular star value. So that is nothing but your reduced bearing. Do we have this expression? Yes, we have it. Option number D. Very good, Dinesh. Option number D is correct. Chalo, next question. Board of this, we'll skip it. Fore bearing, back bearing again, skip it. Okay, let's do this. Question number 50. Dip of magnetic needle at equator and pole is respectively. Hmm. C, yes, very good. So at equator it is 0 and at pole it is 90. So C is the correct answer. Ah, question number 51. A declination of 3 degree east means magnetic north is 3 degree west of true north. True north is 3 degree east of magnetic north. True south is 3 degree east of magnetic south. Magnetic north is 3 degree east of true north. Let's first put this is my true north. Declination of 3 east. East means declination is like this. So this is 3 degree. This is magnetic north. Magnetic north is east of true north. Option number D is the correct answer. Okay, understood. Chalo, next question. Convert this to whole circle bearing into quadrantal. No. The horizontal angle by the survey line with reference to arbitrary meridian passing through one of the extremes is called. So what is the exact definition of this? He is asking. It is nothing but the arbitrary bearing. The angle made by the surveyor's line with respect to arbitrary meridian. So if you are calculating the angle with the help of an arbitrary meridian, then it is called as arbitrary bearing. Not arbitrary meridian, not D, not D. It is A, bearing. They are asking you what is the horizontal angle called. Okay, Dinesh? Chalo, next question. If the latitude and departure of a survey line are negative, then the direction of mentioned line in whole circle bearing system will be in the range of. Latitude is nothing but what? Horizontal measurements. And departure is nothing but vertical measurements. Like this, say for example, if we have north, this is first quadrant, second quadrant, third quadrant and fourth quadrant, south, east and west. He is telling latitude and departure both are negative. Okay, so this, oh, I missed mistake. Okay, so this is what departure is, this horizon. So this is your departure negative, this is your latitude negative. Okay, so the line is coming somewhere here. That's what. So the line is coming somewhere here. So where exactly, in which quadrant it is, in which angle it is coming? 0, 90, 180, 270 and 360. So it is coming in between 180 and 270. So this is your correct answer. Option. Okay. Now, easy, easy. Okay, let's do this. This would be the last question from Compox surveying. Do it. The interior angle of a closed traverse ABCDE are measured as below. Angle A, angle B, angle C is given to you. The bearing of initial line is, the first line bearing also is given to you. The bearing of line BC will be, is asking you what is the bearing of the line BC. Okay. So first of all, try to draw the figure. So north, I will take this direction. First draw the line, first line. So they have given the bearing of the initial line is this much, 217 degree, 50 minute, 20 seconds. So 217 degree means it will come in third quadrant like this, right? This is the bearing. How much? 217 degree, 50 minute, 20 second. Okay, this is the first line. Okay. So say this is your line A, B. Now angle, included angle of B is 112 degree 12 minute. Say if I take this as north and south, so this is given to us. How much? 112 degree 12 minute 00 second. This is the point C. They're asking is, what are they asking us is the bearing of the line BC. So this, I'll put it in green, put it in green. So this is what they are asking. This green stuff or angle they are asking. So already 112 degree 12 minute, this you know. So this portion you have to calculate. This angle you have to calculate. So how will you calculate that particular angle? So if you calculate this, taking the Z angle, you will get this. So how much is this equal to? So 217 degree 50 minute 20 second minus 180 minus 180. So 217 minus 180 would give us how much? It would give us 37 degree 50 minute 20 second. Okay. So this star angle is how much? This. For this, you add 112 degree 12 minute 00 second. So 20 second, 62 minute and 149 degree. 62 minute it cannot happen because 1 degree is 60 minutes. So I have to take it here. So 150 degree 2 minute 20 second. So this is your correct answer. Understood? Okay. Dinesh, I will answer your question. So you're asking the difference between the included angle and the interior angle, right? See now, uh, included angle can be of two types. Included angle can be interior angle or exterior angle. One of the type of included angle is interior angle. Okay, one of the type of included angle is interior angle. But in included angle there are two angles. One is interior angle, one is exterior angle. If you want to take the correct meaning, say if I have a closed traverse like this particular portion angle is called as interior angle, and this particular portion is called as exterior angle. Both are included angles only. One is called as included interior angle, the other one is called as included exterior angle. Now whenever you are doing traversing, see traversing you do either in clockwise direction or anti-clockwise direction. Traversing means what? Constructing this line, one like this, you'll go like this, you'll go like this construction you'll do. No, this is called traversing. So suppose you are going for a clockwise traverse. If your traverse is in clockwise direction, then whatever included angle will be there, no, that will be our exterior angle. That angle we will call it as exterior angle. And if your traversing is in anti-clockwise direction, that included angle is called as what? Interior angle. Okay, Dinesh, did you understand? Okay. So let's, Dinesh, any other doubts you have? So in the next class, okay. So in the next Monday's class, we will discuss some PYQs. I will discuss GATE PYQs. Okay, important PYQs of GATE from the surveying subject, okay, or geomatics engineering subject. So you do attend at 5 p.m. and if you have any doubts, you can get it and ask me so that I can help you to clear that particular doubt. And also tomorrow at 5 p.m. we have doubt clearing session for transportation engineering, subject. So I will get you some problems regarding side distance, overtaking side distance. So you can attend, it will be very helpful because this is a major topic from which 90% chances are there that you will get a question from for your GATE exam. So don't miss the class tomorrow at 5 p.m. So I will discuss in brief about side distance, overtaking side distance, and also solve certain problems related to that. Okay, I'll see what extra things we can do. And if you have any doubts in the transportation engineering, we can connect tomorrow for the session. So, according to the December month schedule, we have one more surveying uh, slot left, which is next Monday at 5 p.m. And talking about transportation engineering too, it will be on Tuesday. It is starting from tomorrow. Okay, so every Tuesday at 5 p.m. Totally three sessions I will be conducting in the subject of transportation engineering. Okay, so any doubts anyone would like to ask? I hope your session was helpful. So for anything more regarding the entire recorded classes for your exams, for your academic courses, for your GATE courses, and for any other professional courses, you can go to our or download our Ekeeda app from the Play Store, or also the link is given in the description box. So go there and uh, download it and install. Currently, there are a lot of offers going on for the subscriptions. You can take them, and you can also use Gold 11 code so that you will get a complete 3 days free access for all the courses in the website, so that you can know how our app works and know more about it. Okay. So any doubts or shall we wind up? Any doubts? Okay. I believe there are no more doubts. So we'll wind up. So uh, I would like to thank Ria, Dinesh, for actively participating in the questions. I hope the session was helpful. Bye. Take care. See you tomorrow at 5 p.m. for the transportation engineering session. Okay.